Hello. This is part one of two of sequences and summation notation. So in this first part, we will go over sequences. In the second video, we will go over sums, summation notation. All right, take notes. We are heading towards the finish line. Okay, sequences and summation notation. All right, so what is a sequence? Okay, so this is basically an infinite list of numbers. So like A1, A2, A3, that's a number, another number, and another one. And it just goes on forever. So A1 represents the first term. This represents the first term, second term, third term, etc. Okay, so for example, you might have this sequence 5, 10, 15, 20, and it goes on and on and on. And this here, this would be our first term, A1. This would be our second term, A2. And this would be A3. And this is A4. And if we listed more, then we would have A5, A6, A7. Okay. So it is a type of function. So it is a type of function whose domain or whose inputs are natural numbers. So normally in those other functions that you have looked at, you can plug in anything for x and see what you get. Like you can plug in 1, you can plug in 0, maybe you can plug in 2, 2.5, 2.7, all kinds of numbers. But here for sequences, you can only input natural numbers. Natural numbers are like 1, 2, 3, 4, 5. Okay. No negative numbers, no decimal numbers, no fractions. Just 1, 2, 3, 4, 5. Okay. And they can be expressed different ways. So let's take a look at that sequence up above. Here, expressing a sequence. All right, so let's take a look at this example. 5, 10, 15, 20, 25, right? Okay, so one way to express it is using this notation, like function notation. Okay, so one way to do this is like a of n. Okay, so a of n, if you notice, it's going to be 5n, right? So if I plug in 1, I get 5. If I plug in 2, I get 10. If I plug in 3, I get 15. If I plug in 4, I get 20. If I plug in 5, I get 25, etc. Okay, so that's one way to do it. Another way to do it is this symbol instead of the function instead of using that. We don't really use this one, but maybe you've seen it before. This is the more common way to represent a sequence. And the 5n we get, that's the 5n, that's like our formula on how to find a term. Okay. And then there's another way, this third way, which is a recursive formula. We could represent the same sequence. If you notice, oh, it's like if I'm asking someone, oh, well, how do you get these numbers? Someone might say, they may not say this. They might not say, oh, you do 5 times n, where n is a natural number. Most people, when you show them the sequence and you ask them, well, how do I get these numbers? And what would be the next number in the sequence? They would say, oh, the next number would be 30 because you just keep adding 5. Okay. So that's probably the natural way to see it. So this formula probably wouldn't come to mind. So this one probably would, where you just add 5 to the one before it. And the one before it gets represented with this, and you add 5. Okay, this one here, where it's dependent on the on the previous term, like knowing you have to know the previous term in order to get to the next one. This here is called a recursive formula. Okay, that's where you need to know the one before it in order to come up with the next term. Okay. Okay, and these symbols here are good to know. So an, that just means the nth term. Of the sequence. And then this one here, that's the term before the nth term. So that's how we represent them. So this might seem abstract because we're using the letters N here, the letter N here. So let's use 5. Okay, so A5 would mean that represents the 5th term. If this is A7, then that's the 7th term. If this is A11, then it means it's the 11th term. If it's A53, then that's the 53rd term. Okay. And then here, AN minus 1 is the term before the nth term. So if we're talking about A11, then this one must be A10. If this is A29, then this is A28, the one before it. Okay, if this is A123, then this one is A122. It represents the term before this one. Okay, and then of course A1 is the first term, A2 is the second one, etc. Okay, A2 is the second term, A3 is the third term, and we can keep on going. A3, A4, A5. Okay. These here make more sense. These are a little bit abstract. These here, we're just talking about this in more general notation. Okay. All right. So let's take a look at example. So here, suppose that I have this sequence 2, 4, 6, 8, 10, ... Okay. So clearly this is A1, our first term. This one here is A2, our second term. This one is A3, our third term. This one is A4, our fourth term. And this one is A5, our fifth term. Okay. this is the way we use the second notation that I showed you up here. If we want to use function notation, then we would just write it like this instead. A of 1, A of 2, A of 3, A of 4, and A of 5. Okay, so that's using function notation. All right, so over here, what we're trying to do is we're trying to find the formula AN. Okay, so over here, we can see that to get the terms, we do 2 times n. Okay, and we can see that because if I plug in 1, 2 times 1, I get 2, which is our first term. If I plug in 2, I get 2 times 2, which is 4, which is the second term. And then if I plug in 3, 2 times 3, I get 6. And if I plug in 4, I get 8. So we see that this here is the nth term formula. Okay, so that if I wanted to find a term somewhere farther down the sequence, I don't have to keep listing them, keep adding and adding and adding, or multiplying till I get there. If I have the formula like I do here, and I want to know what is the 103rd term, right? Then all I have to do is use that formula to find the nth term. So I can just plug in 103 and I get 206. Okay, so 206 would be the 103rd term. Okay, finding terms in a sequence. All right, suppose that you want to find the first 5 terms. Find the first 5 terms, and then also the 10th term. Okay, and we'll do a few examples of these. Okay, so this first one. Suppose that your nth term formula is 2n minus 1. Okay, so this is your nth term formula. So if I want to find the first term, then I would plug in 1. So my first term is 1. If I want to find the second term, then I would plug in 2. And same thing with the third term, the fourth term, and the fifth term. Okay. And so here we get 5. And for this one, we get 7. And then for this one, we get 9. Okay. And then it also says to find the 10th term. So I don't have to go in order. I could go out of order and skip all the way to 10. All I have to do is use this nth term formula here to find the 10th term. And so we see here that we get 19. So our 10th term is 19, while the first 5 are 1, 3, 5, 7, 9. Okay. All right. And let's go ahead and try that for this next one. Suppose that our nth term formula is Cn equals n squared minus 1. Okay, so here you have this formula. And A1, you plug in 1. So we get 0. A2, you plug in 2. A3, and A4. And then we need A5. 25 minus 1, we get 24. And then we want the 10th term as well. So all we do is plug in 10 to see what we get. Okay, so our 10th term here is 99. Okay, go ahead and try it for this one over here. Suppose that your nth term formula is n over n plus 1. Okay, go ahead and try these and come back and check your answers here. Okay, hit the pause button. All right, so A1, get 1 over 1 plus 1. We get 1 over 2. A2, so we get 1 over 2. A2, we get 2 over 2 plus 1. That's 2 over 3. A3, we get 3 over 3 plus 1. So that's 3 over 4. And then A4, we get 4 over 4 plus 1. Kind of seeing a pattern here. Do you see a pattern? So that if you have A5, you're going to get 5 over 5 plus 1. So that's 5 over 6. And then we also want the 10th term. So that's going to be 10 over 10 plus 1. And that will be 10 over 11. All right. Very good. I just need to see something. Okay, the 10th term. Okay. All right. Very good. Let's take a look at this next one just because I want to show you something with this negative number here. Okay, so let's take a look at this one last example for this section here. Suppose that you have this for your Rn formula, negative 1 to the nth over 2 to the n. Okay, so let's take a look and see what happens when we have this negative 1 involved. Okay, so when I plug in 1, I get negative 1 to the first power, and I get 2 to the first power. Okay, so negative 1 to the first power is negative 1, and I get that. Okay, this is our nth term formula. So far, we get negative 1/2. Okay. If I want to find my second term, I plug in 2, and I get 2 squared. Okay. And so then I end up with negative 1 squared is positive, and 2 squared is 4. So we get 1/4. Okay. And if I do my third term, I get negative 1 to the third power and 2 to the third power. So negative 1 to the third power is negative 1. 2 cubed is 8. So I get negative 1 over 8. And if I do that for A4, I get negative 1 to the fourth 2 to the 4th. Negative 1 to the 4th is positive. 2 to the 4th is 16. And if we do, let's just do this last one here, a to a5, the fifth term. So that would be negative 1 to the fifth power, 2 to the fifth power, and we get negative 1 over 32. Okay, so let's skip the 10th term. Okay, so this is what we would have here, right? So what I wanted to point out is that notice how we have this alternating sign happening here. We have negative and then positive, negative, and then positive and negative. So whenever you have that happening, then you are most likely going to have some negative 1 involved in the formula for the nth term, so that later on when they're asking you to find the nth term, or they're asking you to find the formula. So as you inspect your sequence, if you notice that the signs are alternating, then just know that you're going to have a negative 1 to the nth power, or some version of that. Okay? All right, so let's take a look at finding the nth term. Finding the nth term. Some sequences are easier to figure out than others. Finding the nth term. It just depends. And even some sequences are easier for some people, and some other sequences are easier for other people. So when they say find the nth term, they're asking you to find that AN formula. Okay. So finding the nth term is similar to when you guys, maybe back in middle school, you were asked to find the function, similar to finding the function. You looked for patterns. Okay, so that's what you have to do. Here, look for patterns. Okay, and just remember, as you're looking for patterns, remember that your inputs are natural numbers. 1, 2, 3, 4, 5. Okay. So you want to try to ask yourself, okay, when I plug in 1, I get that. When I plug in 2, I get that. When I plug in 3, I get that. When I plug in 4, I get that. Okay. And you just have to be really patient when you do these problems if you can't find the pattern. Okay, suppose that we have this 1/2, 3/4, 5/6, 7/8. When you have fractions like this, to me, sometimes it's easier just to first look at the numerator and try to see if you see a pattern there. And then once you find the pattern for the numerator, then go ahead and take a look at the denominator. This is kind of like almost 2 problems in one, because the numerator will have its own pattern and then the denominator will have its own pattern. Okay, so 1, 3, 5, 7. Those are the odd numbers, 1, 3, 5, 7. When I plug in 1, I get 1. When I plug in 2, I get 3. When I plug in 3, I get 5. When I plug in 4, I get 7. Okay, so hopefully you notice that, oh, okay, here, let's do this. A1, A2, A3, A4. Okay. And you want to see how these numbers, these inputs, when you plug in 1, you get 1. When you plug in 2, you get 3. When you plug in 3, you get 5. When you plug in 4, you get 7. And you want to take a look at how these numbers, when you plug in, how do you get these? So it looks like we double our inputs and subtract 1. So 2n minus 1. And then down below, it looks like we just double our inputs. 2 times 1 2 times 2, 2 times 3, and 2 times 4. So we just double our inputs. So this here is our nth term formula. Okay. Being familiar with odds, how do you represent the odds? And how do you represent the evens? That's kind of good to have in your back pocket. So knowing how both of these are developed is good. Okay. So each of these is good to know because these often show up in patterns. Okay, so if you're like, oh, those are the odd numbers, you're trying to figure out how do I represent the odd numbers like this, 2n minus 1. Okay. All right. Let's take a look at this one. -2, +4. -8, +16. -32. And it just keeps going. Okay. So we see that we have this alternating sign happening here, just like we did up here, which I was trying to warn you about. Over here, negative, positive, negative, positive, negative, right? And I said when you have that alternating sign, then you have that -1 involved in your formula. Okay. All right. So we have that here. And if it helps you to write this down so that you can try to see a pattern between your inputs and your outputs. Okay. Oh, okay. I know. Let's learn how to count, right? 1, 2, 3, 4, and 5. Okay. All right. So we're trying to find our nth term formula. Okay. So we know we're going to have a -1 involved. And it's going to be n. Because when I plug in 1, I get a negative. When I plug in 2, I get positive. When I plug in 3, I get negative. When I plug in 4, I get positive. Okay? So it's going to be -1 to the n. Just make sure you always check because it's not always -1 to the n. It might be -1 to the n plus 1. Okay, so just always check when you plug in these inputs, are you getting the result you want? All right, and then we see that these are all powers of 2. And so we get 2 to the, this looks like when I plug in 1, I get 2. When I plug in 2, I get 4. When I plug in 3, I get 8. When I plug in 4, I get 16. So it looks like it's just this. Okay. So this would be your AN formula. Another way you could write this as well is AN equals -2 to the nth. Okay, so either one is fine. All right. Let's take a look. Okay, let's revisit recursive formulas again. Okay, so recursive defined sequences. So these are the ones where the formula is written in such a way that it depends on knowing the term before it or the previous terms before it. Okay, so a sequence whose nth term depends on some or all terms preceding it. Okay, so let's take a look. So if I give you the first term and I tell you that it's 1, and I give you the nth term formula, which is a recursive formula, and I say that your nth term formula is 3 times the term before it, plus 2. Okay? So remember, this is the representation for the term before this one. Okay? So if we're trying to find A5, the 5th term, this would have to be the 4th term. If I'm trying to find the 11th term, this is the 10th term. Okay? All right, so find the first 5 terms. Okay? All right, so we already know A1. A1 is 1. It's given. Okay? Now, if I want to find A2, now I'm going to go ahead and use this formula. A2 is equal to 3 times, this is the one before it, so this is going to be A1. If this is A2, this is A1. If this is A5, this one's A4. If this is A79, this is A78. Okay? Okay. And we do know what A1 is. It's 1. So we get 9. Okay. If I want to find A3, then I'm going to use the recursive formula. 3 times, again, if this is A3, this will be A2, the one before it. So A2, we already found it. It's right here. It's 9. So I get 33. Okay. And then A4. Here, let me bring this down a little lower. A4 is going to be 3 times. This is going to be A3 plus 2. And A3 is 33 plus 2. So 3 times 35, which is 105. Okay. And then A5 will be 3 times. This is going to be A4, the one before it, plus 2. So this is going to be 3 times 105 plus 2. 3 times 107, and we get 321. Okay, so the first 5 terms are going to be 1, 9, 33, 105, and 321. Okay. All right. Okay, there is a very popular sequence called the Fibonacci sequence. So we can't talk about sequences without talking about Fibonacci's famous sequence. Okay, so Fibonacci sequence. All right, it's defined by a recursive formula. So I have to give you the first 2 terms. So, and we'll call it F1 instead of A1 since this is a very special sequence. It's Fibonacci's sequence. All right, F1 equals 1. So the first term is 1, and the second term is 1. And then to find the rest, to find the third term, the fourth term, the fifth term, you can use this formula now. You take the one before it, and you add the one, you add that with the one that came before that one. So this might look a little abstract, but all this is saying is if you're going to find the 5th term, then you add the one before it, which is the 4th term, and the one before that, which is the 3rd term. So if this is the 5th term, the 4th and 3rd. Okay. If this is the 11th term, then it's the 12th, the 10th and the 9th. Okay. If this is the 50th term, then this is the 49th and the 48th. If this is the 90th term, then this is the 89 and 88. Okay. That's how you read that. You can think of it as, oh, this means the one before it, and this means two before it. Okay. All right. So find the first 10 terms. I'll probably post a YouTube video about the Fibonacci numbers. Okay. Just so you can see why it's so famous. All right, so we know that the first term is 1, the second term is 1, and then to find the next one, we add the 2 before it. So if I want to find this one, I have to add the 2 before it, right? So 1 plus 1 is 2. If I want to find this term, I add the 2 before it, so it's going to be 3. The next one, I have to add the 2. 5, and then 8, and then 13, and then 21, and then 34, and 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here are the first 10 terms of the Fibonacci sequence, and it can keep on going. Okay, so that is it. Fibonacci sequence is famous because it's found this pattern of numbers is found a lot in nature. It's found in the way trees branch out. It's found in the spirals of pine cone, nautical shells, all kinds of things. So that's why this is a very interesting sequence to people. Okay, so that is it for the first part of this section. In the second part, we will be going over partial sums. How do we add the sum? How do we find the sum of part of the sequence?